In today's lesson, we'll be learning how to solve linear systems by elimination. The technique we're learning in this lesson is very similar to the technique you learned in the previous lesson. However, there is one extra step. We're going to begin by stacking each equation on top of one another. Let's write equation 1. X plus 2y equals negative 4. And underneath it, I'm going to write equation number 2, which is 3x minus 4y equals 18. Let's check to see if like terms are on top of each other. X and 3x are like terms. Positive 2y and negative 4y are like terms. And negative 4 and positive 18 are like terms as well. Therefore, we can proceed to step 2. In step 2, we want to multiply equation 1 or 2 such that one pair of like terms becomes identical. Over here, I have x and 3x. They are like terms, but they're not identical. Over here, I have 2y and 4y. They are like terms, but they're not identical. And over here, I have negative 4 and 18. They are like terms, but they're not identical. Therefore, we're going to try and multiply one of the equations such that one pair of like terms becomes identical. Let's rewrite our equations on the right. So I have x plus 2y equals negative 4. And underneath it, I'm going to write 3x minus 4y equals 18. We can try to get these two terms identical, or we can try to get these two terms identical, or these two terms identical. Let's start with the first pair of terms. I have an x and I have a 3x. How can I get x to become 3x through multiplication? Well, if I multiply x by 3, that should give me 3x, which matches the 3x I have down below. Let's make a little note for ourselves. I'm going to multiply that by 3. Now, if I multiply one of these terms by 3, I have to multiply everything by 3. So I'm going to have to multiply that term by 3, and I'm also going to have to multiply that term by 3. Let's write the work for that down below. So I'm going to rewrite my first equation, which is x plus 2y equals negative 4. I'm going to make a little note for myself. I'm going to say equation 1 gets multiplied by 3, which means everything gets multiplied by 3. Let's do that on the side. First, I'm going to multiply x by 3, which becomes 3x. Let's write that here, 3x. Now I'm going to multiply positive 2y by 3, and that becomes positive 6y. So I'm going to write positive 6y over here. And last but not least, I have negative 4 multiplied by 3, which becomes negative 12. So that becomes negative 12. This becomes my new equation 1, which I'm going to use in my next steps. And now let's zoom out to take a look at all the work that was required for this very first two steps. Step 3, we want to add or subtract equation 1 and 2 to eliminate a variable. Let's zoom in because we're going to need a lot of space to do this question. We're going to rewrite equation 1. Remember, we manipulated equation 1 in our last step, so let's use that version of equation 1, which is 3x plus 6y equals negative 12. And let's rewrite equation 2, which we haven't manipulated yet. So it's just 3x minus 4y equals 18. You'll notice that one set of terms are identical. 3x is identical to 3x. That is what we want. That is a reason why we manipulated equation 1 in our last step. At this point, we want to either add or subtract these two equations. choice is yours. However, there is usually just one correct way, and in this situation, it is subtraction. So let's go ahead and subtract these two equations, and by doing so, we're going to eliminate a variable. So I have 3x subtract 3x, which is just 0. I'm not going to write that in. And next, I have positive 6y subtract negative 4y. And if you recall, when you have two subtraction signs beside each other, that becomes addition. And what we have here is positive 6y plus 4y, which is 10y. And I am going to write that in right over here. And last but not least, I have negative 12 subtract 18. And you need to use your number line or a calculator, and that is going to be negative 30. So that is equal to negative 30. Once we get 10y equals negative 30, we want to isolate y, but y is stuck with this 10. When you have a number beside a variable without any operation, it is multiplication. So this is secretly multiplied by 10, but we want to get rid of it, so we're going to do the opposite. We're going to divide both sides by 10. Let's go ahead and do that. The 10s cancel out, which leaves us with y, and negative 30 divided by 10 is negative 3, because when you have a negative divided by a positive, you get a negative number. Now that we know that y is equal to 3, we can go ahead to our next step, which is step number 4. And we are going to need a lot of space for this question as well. Step 4, we want to substitute the variable from step 2 into either equation 1 or 2, and we want to solve for the other variable. Let's begin by choosing an equation. You have a choice between either equation 1 or 2. You'll get the exact same answer either way. Let's start with equation 2. So I have 3x minus 4y equals 18. I'm going to write a little instruction for myself. I'm going to say substitute in y is equal to negative 3. Now, instead of writing y, I'm going to replace it with negative 3 in brackets. Okay, and everything else stays the same. The 3x stays the same, but now let's multiply negative 4 and negative 3. Negative 4 times negative 3 is positive 12, because when you multiply two negative numbers, you get a positive, and everything else stays the same. At this point, you have 3x plus 12 equals 18. Remember, you want to isolate x. You want it all by itself. However, it is stuck with this 3, and it is stuck with this positive 12. Let's get rid of the positive 12. The opposite of positive 12 is negative 12. Therefore, I'm going to subtract 12 from both sides of the equation. And everything else should stay the same. So, positive 12 minus 12 cancels out, which just leaves you 3x, and 18 subtract 12 is 6. Now, we want to isolate x, but x is stuck with this 3. When you have a number beside a variable with no operation, it is multiplication. So this is multiplied by 3. The opposite of multiply by 3 is divide by 3. Therefore, I'm going to divide both sides by 3. Those 3's cancel out. X stays the same, and 6 divided by 3 is 2. Therefore, you know the value of x and you know the value of y. So let's do a concluding statement. I'm going to say, therefore, the point of intersection is 2 and negative 3. And let's zoom out to show you all the work that was required for this question. In our second example, we want to solve the linear system by elimination. We're going to begin by stacking the two equations on top of one another. I'm going to write 8x plus 5y equals 12. And underneath it, I'm going to write 2x plus 3y equals 10. As you can see, 8x and 2x are like terms, positive 5y and positive 3y are like terms, and 12 and 10 are like terms. And they are stacked on top of one another, which is what I want. Now in step 2, we want to multiply equation 1 or 2 such that one pair of like terms become identical. Let's begin by rewriting our equations. I have 8x plus 5y equals 12, and I have 2x plus 3y equals 10. Now let's analyze these like terms. 8x and 2x are like terms, but they're not identical. Positive 5y and positive 3y are like terms, but they're not identical. 12 and 10 are like terms, but they're not identical. So we need to manipulate one of these equations. Let's take a look at the first pair of like terms, 8x and 2x. I need to multiply either 2x so that it becomes 8x, or I can multiply 8x so that it becomes 2x. The much easier route is to multiply 2x by something so that it becomes 8x. And what can I multiply 2x by to get 8x? I can multiply that by 4. And if I multiply that by 4, everything else needs to multiply by 4 as well. Let's go ahead and make some notes for ourselves so that we don't get confused. Let's rewrite equation 2, which is 2x plus 3y equals 10. The note I'm going to write is this. Equation 2 gets multiplied by 4, which means everything on both sides of the equation gets multiplied by 4. Let's go ahead and do that. I have 2x multiplied by 4, and that is 8x. So I'm going to write that over here, 8x. Now I have positive 3y multiplied by 4, and that becomes 12y. And I'm going to write that down over here. I do need to add an plus sign beside these two terms. And last but not least, I have 10 multiplied by 4, which becomes 40. So I'm going to write 40 over here. So 8x plus 12y equals 40 is your new equation 2. I'm out to show you all the work that was required for this section. In step 3, we want to add or subtract equation 1 and 2 to eliminate a variable. Let's zoom in here because we're going to need a lot of extra space. Let's begin by rewriting our first equation, which is 8x plus 5y equals 12. Now we're going to rewrite the equation 2 that we manipulated. We manipulated it into 8x plus 12y equals 40. Why did we manipulate it? We manipulated it because we wanted one pair of like terms to be exactly the same. So 8x is identical to 8x. That is what we wanted. Now we want to add or subtract these two equations such that one of the variables gets eliminated. Now, I already know that you need to subtract these two equations. However, if you added, you would quickly realize that that was not the right route to use, and you would have backtracked and used subtraction. So let's write a little note that equation 1 is subtracting equation 2. So let's do some rough work on the side. 8x subtract 8x is 0. I'm not going to write that in. Next, I have positive 5y subtract positive 12y. Now, when you have an addition sign and a subtraction sign, that simplifies into a subtraction sign. So positive 5y subtract 12y is negative 7y. 7y. So here you get negative 7y. And last but not least, you have 12 subtract 40, and that is equal to negative 28. So I'm going to write negative 28 over here. We have negative 7y equals negative 28. We want to isolate y, but y is stuck with this negative 3. When you have a number beside a variable without any operation, it is multiplication. Therefore, we have multiplied by negative 7 here. To get rid of it, we need to do the opposite to both sides, so we need to divide both sides by negative 7. Let's go ahead and do that. I'm going to divide that by negative 7, and I'm going to divide that by negative 7. Those negative 7s cancel out. The y stays exactly the same, and now you have negative 28 divided by negative 7, which is positive 4, because a negative divided by a negative is positive. Now that you know the value of y, you can proceed to the next step. So in step 4, we want to substitute the variable from step 2 into either equation 1 or 2 and then solve for the other variable. You can choose either equation, you'll get the same answer. I'm going to use equation 1. So I'm going to use 8x plus 5y equals 12. I'm going to make a little note up for myself that I'm going to sub y equals 4. When I sub y equals 4, I replace the y with the value of 4. Everything else stays the same. 8x stays the same. The 5 stays the same. I'm going to replace y with 4. And the 12 is the same. So the 8x stays the same. Positive 5 multiplied by 4 is positive 20. And that 12 stays exactly the same, which leaves us 8x plus 20 equals 12. Remember, we want to isolate x, therefore we need to get rid of this 8 and this plus 20. Let's get rid of this plus 20 first. So the opposite of plus 20 is subtract 20, which means we're going to subtract 20 from both sides of the equation. So 8x stays the same. I'm going to subtract 20 here. And I'm also going to subtract 20 on the other side of the equation. That cancels out, so I'm left with 8x equals 12 subtract 20, which is negative 8. Point, you want to get rid of this 8. When you have a number beside a variable without any operation, it is multiplication. So that is multiplied by 8. The opposite is divide by 8. So we're going to divide both sides by 8. Those 8's cancel out, so we're left with x is equal to negative 8 divided by 8, which is negative 1. Or we know the value of x and we know the value of y, and we can state the solution, the point of intersection. So let's write a little concluding sentence. Therefore, the point of intersection is negative 1 and 4. Zoom out to see all the work that was required for these last two steps.